Section 1.3 Continuity. Example 2. Determine where the function f of x equals x squared over x minus 1 is continuous. In order to find where the function is continuous, we refer back to the continuity definition. So the first thing we need to find out is where the function is defined. And we can only check that those intervals for continuity. So first we need to find the domain. Now the domain would be negative infinity to infinity unless there are restrictions. And we do see a denominator. So the restriction is the denominator cannot be 0. Okay, so when will the denominator equal 0? Is when x equals 1. So what it means is x cannot equals 1. So how to write in the interval notation? I'll draw the number line, find the number 1 right here. Okay, and it's a whole, it cannot equals 1. But the rest is okay. So from left to right, right? So it's negative infinity to 1. We cannot take 1. Union from 1 to infinity. So that is the domain and that is the interval we want to investigate. Well, we know f of x is defined on this interval because the denominator is not 0. So once we know where f of x is defined, we want to find out where f of x has a limit. So we find limit as x goes to c, and we want c to be in this interval. Okay? So c is not 1. For any c that is not 1, this limit x goes to c, x squared divided by x minus 1. When c is not 1, c minus 1 is not 0. So it is okay, we can do a plug-in. Direct substitution. So this limit is just c squared divided by c minus 1, and the denominator is not 0. So this is a valid evaluation. And this is exactly the value f of c, which is satisfied the third condition. So our conclusion is f of x is continuous on its domain. And this is most likely the case for most functions except piecewise function that you do need to check the endpoints.